All right, so this problem is a horizontal circle problem. So like I told you, when you're drawing a horizontal circle, make it look like an ellipse, flatten it out, and that way I'll know that if I see this, this is a horizontal circle, and if I see an actual circle, that will represent a vertical circle. Because I'm trying to make this three-dimensional. And there's actually three different dimensions that, like, if I draw the force that's going to cause the change in direction on here, there's still two directions that could be perpendicular to that. Just like if I look at the x direction, the y direction and the z direction are both perpendicular to the x. So in this problem, it says that a coin is placed in a record and then it revolves at a certain speed. And it says that it will stay with the record as so long as you don't put the coin further than 10 centimeters away. Because if you put it outside 10 centimeters, apparently there wouldn't be enough friction to keep it moving in a circle. So now the 30 centimeters that they give here, that's not even a fact that's relevant to the problem, because I'm not going to use that number other than in drawing the picture. I suppose I can, knowing that number, I can draw where the coin is located to scale. Because 30 centimeters just means that from one end of the record to the other end of the record is 30 centimeters. So if that's the case, then from the middle of the circle to one end is 15 centimeters. Yes? I'm not going to need it to solve the velocity. No, I'm going to use the 10 centimeters because the velocity is the velocity of the coin. So the radius that the coin will be moving through will be a radius of 10 centimeters, not 30. Or not 15. So 15 just means that from the center of the circle to the end of the record is 15. And I am going to be putting the coin then 2/3 of the way out. All right, so there's my coin. That's going to be 2/3 of the way out. So the only force that's causing that coin to change direction is the friction between the coin and the record. Now, because the coefficient of friction is what we're looking for, then I also want to include the forces in the y direction. So I also want to include that the weight is down and the normal force is up, and I'm going to need those. So we're going to have, this is the friction, this is the weight, and this is the normal force. So that is what your picture should look like. And obviously it's a good thing that the record was 30 centimeters and not, let's say, 18 centimeters, because if it was 18 centimeters, then the coin would not even fit on the record. So it would have to be the number that they gave me up here of 10 centimeters better be something less than 15, because after 15, I'm not even on the record anymore. So that's one piece of information that I guess that's one reason for knowing the diameter of the record. So once we have the picture, then we can draw our descriptive equations. So we sum up our forces that are centripetal. We're going to get friction is the only force that's causing the change in direction. And friction is going to equal ma, because anytime we sum up our forces, they equal ma. But in a circular motion problem, the a is either v squared over r or r omega squared. So friction, bless you, friction is going to be the mv squared over r or mr omega squared. And remember I told you that the default should be mv squared over r. Because if I use mv squared over r, all my units will always cancel out, and I'll get my answer with I'll get my answer in newtons in this particular problem. If you use mr omega squared, there's only two times you have to use it, and those would be the only two times that I would, well, there's only one time you have to use it, and the other time that I would probably still use it. And that's when, if the r is the unknown, you have to use it. Because there's no other way to solve for the r unless you use mr omega squared. And the other time I would use is if they do give me the angular velocity in radians per second, then why bother doing a conversion? If I have the number, I would just use that. But in this problem, they're not giving me the angular velocity in radians per second, so I am going to use mv squared over r. All right, so that's my centripetal force equation. And now when I sum up my forces in the y direction, I'm going to have the normal force minus the weight, and those equal 0, because these two forces have to balance out, because this thing is only going to move in that plane. So it's not going up or down. It's just moving in a circle. So once you have that, well, if I know the normal force equals the weight, and what does the weight equal? What does W equal? Well, it equals that, but what else does it equal? What? Mg. So if the normal force equals the weight, and the weight equals mg, then the normal force can be replaced with mg. And I know friction equals mu Fn, so what I can do is write that mu mg equals, I'll do it in this color, equals mv squared over r. So all I did was take this equation and replace friction with mu mg, and then I just rewrote mv squared over r. And so with that answer, notice the masses cancel out, so you don't need the mass. And if I solve for mu, I just have to divide both sides by g, and you get v squared over rg or over gr, doesn't matter. You guys back there paying attention? So now, once I have that, let's just plug in the number. Oh, well, we have, if you can see here, we have the r, so the r is going to be the 10 centimeters, which I need to have in meters, and g is 9.8 meters per second squared. But I don't have v, so I am going to have to do a conversion to get v. So somewhere here, you're going to write that v equals, now my starting point is the speed that I do know the record's moving at, and it's moving at 33 RPMs. So 33 RPM, know that that means 33 revolutions per minute. I've had people write radian per minute, and they get it wrong because they put R as radian. R in the abbreviation RPM means revolutions. Bless you. So we're going to write 33 revs per minute, and we're going to convert that into meters per second. So I can do that in 2 steps, in 2 conversions. So I'm going to go from revolutions to meters, and I'm going to go from minutes to seconds. 1 minute is 60 seconds, and 1 rev is what? What distance do you travel when you do 1 revolution around a circle? 2 pi r. So it's going to be 2 pi, and for the r, I'm going to put in 0.10 meters. Because 10 centimeters is 0.10 meters. And what do you get when you solve that? So 33 times 2 times pi times 0.10 divided by 60. Is that it? I think that's it. 0.346 rounded off? Yeah. So 0.346 meters per second. So check your numbers there. Maybe we're missing something. And so once I have that, I can plug it into the formula. Mu equals v squared divided by rg. So 0.346 meters per second. For the r, it's going to be 0.10 meters, and g is 9.8 meters per second squared. So you can see here, if you look at the units, I get meters squared per second squared above, and I get meters squared per second squared below. So mu, we know mu doesn't have any units, and it's not going to have any units here. So I know mathematically I did move things around correctly so that I wouldn't get units. And what is the mu comes out to be 0.122? Yeah. Okay, so 0.122. Now for part B, so there's your answer for part A. For part B, that's not going to change. All you're doing is you're just taking the same record player with the same coin, and you're having it go at a different speed. Now, 33 RPMs, that's the speed that an album would move at. You've ever had an old record player and you have the actual albums, vinyl records, and you put them on the record player. If you're playing an album, you put it at 33 RPMs. If you want to play a single, you put it at 45 RPMs. So singles actually go at a different speed. And even the record itself, if you have a record player, a lot of times what they'll have is on like the singles, there are these little plastic pieces that you can snap in, because when you play an album, there's only a little hole for the album. And when you play a single, it's a bigger hole. And so to play it on the same record player, you have to either use one of those little pieces, or like my record player, I remember had this piece that I could rotate it up, and so it would just give me a different size thing that the album, that a single could fit on there securely. So that's your answer for part A. So for part B, now our equation isn't going to change other than, we still have the same picture for part B. So part B, we still have, this is the same picture. So this is still going to be the same, but what I'm going to do is, if you look here, it says how far from the axis can the coin be placed? So the unknown in part B is the R. So I can't set friction equal to mv squared over r. So what I'm going to do is I am going to write, from when I sum up my centripetal forces, I'm going to make friction equal to mr omega squared. So that's going to be my equation for part B, because r is the unknown. The reason why you cannot use this formula is because v has r hidden in it. Like v equals r omega. The velocity is dependent on the radius. And I need all my r's exposed so that when I rearrange the equation, I will actually be able to get r by itself. Like some might say, well, why can't I do this? Can't I just move the r up here and move the friction down there? You can't do that because, again, you still have r's on that side because v equals r omega. So now they're all out in the open. So if I sum up the forces in the y direction, they're the same. I'm just going to repeat it. So Fn minus W equals 0. And since Fn equals W and W equals mg, then I can replace friction with mu mg. So my equation is going to be mu mg equals mr omega squared. Everyone follow that? So this is mu Fn, and that's friction. So all I did was I just replaced friction with mu mg. I kept this side the same. And the unknown is r, so I'm going to rearrange this equation to solve for r. So r is going to equal, the masses cancel out also, so I can do that. Notice that it doesn't matter what the mass is for either one of these problems. So r is going to equal mu g over omega squared. So that's our formula. Now we are going to have to, I have mu 0.122, it's right there, and g is 9.8 meters per second squared. But I don't have my angular velocity in, I don't have it in radians per second. So I have to do a conversion to get that number, and then I'll have all the numbers I need to calculate r. So the next step is to get the angular velocity. So the angular velocity, which is what we call omega, the W-looking thing, my starting point is 45 revs per minute. So we have 45 revs per minute, and I'm going to extend the line. I'm going to go over 15 minutes again. I just can't do this problem in under 15. I'm going to stop it here, and then I'll just make it